In this section, we will talk about the organization of the elements in a systematic way, and in particular, what has resulted is called the periodic table. Dmitry Mendeleev was the first person to recognize a systematic pattern of organizing the various known elements of his day. He organized a crude periodic table by organizing the elements in terms of increasing atomic mass, and then repeated any kind of organization if the elements had similar possible charges for ions. So, for example, he grouped together elements that formed 1 plus ions, things like hydrogen, lithium, sodium, potassium, so on and so forth. Also then organized the elements that form 2 plus ions and 3 plus ions and so on and so forth, and put these in column form. This presented a possibility of there being holes in his periodic table, which suggested that these were elements yet to be discovered, and indeed many of those holes were filled in short order. We now use the periodic table to help us understand how electrons are organized within the various atoms, and it becomes extremely useful then for predicting things associated with bonding. In the periodic table that you see here, it's been color-coded in terms of when the various elements were discovered. We have a variety of elements that were known from ancient times. The so-called coinage elements, copper, silver, gold, are all named from Greek or Latin names. And so cupris, agaros, and gold is oros. And then we have Hg, which is mercury. That's hygroagaros, which is in Greek means liquid silver or water-like silver. There's ferros, and which is iron. And then we also have carbon, which is a Latin name, and sulfur, tin, and lead. Lead is an English name, but Pb, the symbol, comes from plumbum, the Latin name, which is the metal that was used to do plumbing. The more recently discovered elements are all named after people's names. These oftentimes are very, very radioactive and not very stable. There are then a variety of elements that are then given a variety of names from different sources, oftentimes depending upon the person that discovered it would be given the choice of how to name it. The periodic table has different groupings of elements. The columns are given letter and Roman numeral designations. There are the group Roman numeral 1A, which is hydrogen, lithium, so on and so forth, and then there's Roman numeral 2A, beryllium, magnesium. Then the remaining A group elements are off to the right here. Boron is 3A, carbon 4A, so on and so forth. We also have the groupings of B. These are metals. These are the inner groupings of metals, sometimes referred to as transition metals. We give the different regions of the periodic table various names. So the A groupings are the so-called main group elements. We have the transition metals, which are the B group elements. They form a transition between the main group on the left and the main group on the right. And then we also have the inner transition metals, sometimes referred to as the lanthanide and actinide elements. Here we have color-coded the elements in terms of their properties of metallic or non-metallic character. The vast majority of the elements on the periodic table are metals. Metals tend to conduct electricity and heat very well. They tend to be solids at room temperature, although there's at least one example of a liquid, mercury. Um, and so they tend to be solids that can be formed into wires, therefore they are ductile and also can change shape relatively readily when hit with a hammer, so they are malleable. The nonmetals have properties that are exactly the opposite. They tend to be gases and liquids rather than solids, although some of them are solids at room temperature. But they tend to be brittle. If you hit them with a hammer, they break and fracture, and they do not conduct electricity or heat very well. There are a series of elements in between the metals and nonmetals that sort of form a staircase that are shown in green here. These are these so-called metalloids. I like to refer to them as the confused elements. They tend to have properties that are both of the metals and the nonmetals. And oftentimes these are elements that have conducting properties that are in between that of the metal and the nonmetal, so we refer to them as semiconductors. Oftentimes they are solids, but relatively low melting, and it turns out that these have become increasingly important in terms of modern society because things like elemental silicon are used to make computer chips and various other electronic devices. Finally, we have names associated with the various columns, and in this case we refer to the columns as groups, or sometimes called families. These are elements that tend to have very similar chemistry. The families tend to form the same charged ions, much like Mendeleev noticed. But there are small variations, mostly in terms of size. In addition, there are systematic changes associated with going from left to right in a row of the periodic table, and so these are referred to as periods, and we have what we refer to as periodic changes in the chemical and physical properties of these elements.